Hey everybody, Mr. Enyart here with lesson 12 in Engage New York or Eureka Math. Today we're going to be learning about a new tool to help us with ratios, but first let's review the tools we do know already that help us with ratios. So one of the first ones we learned was tape diagrams. So if we had the ratio of 3 to 2, which represents x to y, then that would be a strip of 3 equal pieces on top of a strip of 2 equal pieces. And so we can see that each piece was represented by 1, and I can show equivalent ratios by simply changing the value inside of each equal piece. So we could say that this was now worth 5, this is therefore worth 5, so on and so forth, and that's going to make our ratio now 15 to 10, which still follows the same ratio of 3 to 2 because this is times 5 and this is times 5. Now with tables, we can see that there's a rate of change in the columns as well as with the overall ratio connection between x and y, so the rows. So I could say that y is always 4 times the amount of x, and I could say that to get from x to y, I would do times 4. And then I would also be able to say that in this table situation, sorry about that, I am moving, when I go down it's plus 2 on the x side, and on the y side it's plus 8. But with my original ratio, this would just be times 3 and times 3. This would be times 5, and this would be times 7 times 7. So this is going to be our new tool. It's called double number lines, and we're going to use this problem to help us figure out how to use double number lines and draw them and see how they help us with ratios. So let's just jump right in. A 12-ounce bottle of sport drink contains 27 grams of sugar. Boom, here is the best sports drink ever, and as you can see it is 12 ounces of sugar, 12 ounces of drink, and it is 21 grams of sugar. So here's our visual for that. Let's keep reading. If Claudia wants the maximum number of grams of sugar she drinks to be 7 grams. Well, remember, if she drinks this whole bottle, it'll be 21, so she's not going to be able to drink the whole bottle. How many ounces of the sports drink can she have? So here's Claudia, and she says, "Hi, my name's Claudia, and I want some juice, but I can only drink 7 grams of sugar, not 21, so I can't drink this full thing of the best sports drink ever. I need to only have some of it. How can I figure out how much sports drink should I do?" So step 1 is to draw 2 arrows that look like numbered lines like this and labeling them in what you're looking for. So this will be our ounces, this will be our grams. Doesn't matter that they're different labels, because obviously an ounce is not the same as a gram. What's going to matter is that the ratio is going to stay the same because, again, these are tools that help us with ratios. Now this is really no different than setting a table at 12 and 21, turning it sideways, and throwing a couple arrows on it right here at the end. You'd have one column, ounces at 12, grams at 21. But in this one, with it being a number line, we know that the back here would represent 0 for both of these, right? So we want 0 to 21 be represented here. We want 0 to 12 be represented by here. Well, they can't both be divided by 2. But I can divide both of them by 3, which means if I cut both of them into thirds and do the same thing here, then each of these represents 1/3 of 21. Terrible lines, I apologize. And each of these represents 1/3 of 12. So you could come back and I cleaned it up a little bit because it was bothering me, but if we're going from 0 to 21 in 3 equal parts, then each part here is 7, 14, 21. And if we're going to 12 in 3 equal parts, then it's going to be 4, 8, and 12, which means here's our answer, 7. If she wants to drink 7 grams, that means she can only drink 4 ounces. So here you can see how the double number line can help us as long as we're kind of keeping the same ratio from the 12 to 21, which a little bit erased, but there's a 1 here. So 12 to 21, and then what we did was we broke it into 3 equal pieces because both 12 and 21 can be divided by 3. So this is your review, how we can use tables, tape diagrams, and now our new double number line down at the bottom here to help us with ratios and finding equivalent ratios. So with the table, we see that we have a relationship going down, which is just +2 on the x side, and then +8 on the y side, but across we have our ratio relationship of 1 to 4, which means y will always be 4 times as much as x. So 3 times 4 is going to be 12, and 5 times 4 is going to be 20, etc., etc. Over here, this shows the exact same thing. This is a 1 to 4 ratio, which means y is always going to be 4 times as big as x, and I can demonstrate that by putting a 3 inside each box since they are all the same size, and that creates 3 to 12, which of course 12 is 4 times as much as 3. So again, my ratio is accurate. And now on the double number line, if we are at 0 here, we can go ahead and do an equivalent ratio of 3 to 12 here. 3 can be broken into 3 equal pieces, which would make it 2 and 1. And 12 can be broken into 3 equal pieces, which would be 8 and 4. And we also have the 0 there. So that shows that 2 to 8, 1 to 4, 3 to 12. I can continue by 4 on the bottom side and then 1 on the top side. So this would be 4 and this would be 16. I could do another one. This would be 5 and this would be 20. And all of these will be equivalent because of my equivalent ratio rule, that both sides have to grow by the same rate of change, which would be times 4 from the original ratio. So 1 to 2, the number that's connected on the y side has to be 4 times as much. Whatever's on this side would be 4 times less than what's on this side. Hopefully this helps. Good luck with lesson 12. And if you have any more questions, don't forget to message Mr. Enyart on Schoology or comment back on this video if possible.